Okay, this is going to be a synopsis on the Energy Conservation Code and how we comply with it and when and where you should apply it. So, first things first, the International Code Council does the IECC, the International Energy Conservation Code. What version of it you will need to comply with, you'll have to check with your local building official to determine that. So, for example, here in Louisville, Kentucky, they require compliance with the 2009 Energy Conservation Code for residential code and the 2012 International Energy Conservation Code for commercial buildings. All right. So, the IECC has two parts. It has a residential part and a commercial part. One of the first things you want to do is determine what your building type is and what section or version of the IECC you need to comply with. That's done sort of in the scope and administration, and within that the definitions. So here, residential buildings shall meet the provisions of the IECC residential. Commercial buildings shall meet the provisions of IECC commercial. Okay, don't just naturally assume that their definition of residential buildings versus commercial buildings is the same as the International Building Code, because interestingly enough, it's a little different. So for the purposes of the IECC, residential building vis-a-vis the residential code includes 1 and 2 family dwellings for multiple single family dwellings and townhouses. And this is where it changes from building code and group R2, R3, and R4 buildings 3 stories or less in height above grade plane. What does that mean? That means if I'm doing, for example, multifamily housing R2 that's a walk-up garden style, 3 stories, then I need to be running a Reschecks versus a Comcheck. What is a Reschecks versus a Comcheck? Well, allow me to explain. You could go through the International Energy Conservation Code and make your walls meet the requirements of this code. However, the federal government and every jurisdiction I've ever done work in allows you to submit, in lieu of compliance with this code, a Reschecks or a Comcheck on a per building type basis. And all they are is effectively a piece of software that you can either download or you can run directly from their website. And what it is just a simple way for you to prove that you are in compliance with IECC. Of course, ASHRAE's in there too, but I always try to stay with the International Energy Conservation Code. They even go so far as to say it on the Comcheck and Reschecks websites, that Comcheck simplifies compliance for building officials, plan checkers, and inspectors by allowing them to quickly determine if a building project meets code. That is true. What it's also doing, which is extremely helpful, is allowing you to balance your selections for energy efficiency for your envelope components in such a way to make the building potentially more cost effective. What do I mean by that? Well, we'll get into it by running one of these examples later on in this discussion, but for the simplicity's sake, I don't have to go say that my walls are going to be, for example, R21 bad insulation. I can say that my walls are R19 and then add more insulation to my foundation or my roof, or increase the U factor of my windows, or all three, to go down to R19 bat and then pass my Comcheck or pass my Reschecks. And that will be, in the eyes of building inspectors and the eyes of code reviewers, compliance. And that can lead you to be able to save a lot of money on the construction costs for the project, especially if you have multiple buildings on a single site. So while we're here, let's talk about the main differences between Rescheck and Comcheck. Intrinsically, they're very, very similar as far as the architect is concerned. Obviously, the Comcheck is sort of the commercial check for energy compliance, and the Rescheck is the residential check for compliance. And that goes back to what we just talked about. Do I need to provide compliance for a Rescheck, or do I need to provide compliance via a Comcheck? Do I need to check my building do I need to prove that my building meets energy code for a residential building, or do I need to prove that my building meets energy code as a commercial building? That's one key difference. The other key difference in the Comchecks is that your mechanical engineer and your electrical engineer will also have their parts to play. They will have their own sections that they need to fill out and they need to comply with. Rescheck doesn't really have a place where the mechanical and electrical input values. They do have a checklist that if you're using Rescheck correctly, you should agree to. And that will involve doing certain things on the mechanical systems and on the electrical systems, like potentially insulating pipes, for example, and sealing penetrations that you agree to do and do a blower door test. And these things overlap what the mechanical engineer is doing or the electrical is doing, and they need to be made aware of it. But you don't have to work directly with them to complete a full Comcheck. You can pretty much do a Rescheck on your own and just send it to them and say, hey, FYI, our Rescheck based on this climate zone and this code that we have to meet, for a year, which you pick inside the software, means we have to do XYZ. Okay? Alright, that should pretty much cover why you do a Rescheck, why you do a Comcheck, and how it is tied to the IECC and it gets tied back to local governing codes. From here, let's dip in and do a Rescheck. Okay, so now that we've done that, what I want to do now is kind of run through a Rescheck real quick. You have two options when you want to run it. You can download the software and run it as a PC program, which is the way I recommend doing it, because then you can save your files off of the online thing, and that you can actually have a file that you can send out to folks. Or you can run their web-based program, because I have, predominantly because these .gov folks haven't written their software code in such a way that it works with high-def monitors, even though every other piece of software does. I'm going to run the web version. It looks a little bit different, but everything is exactly the same as you would as if you were running it from the software from your computer. The same things apply. You need to give the job a name. You need to choose what energy code you're designing to. You need to put in the location of the job, city and state. That'll determine for you your climate zone, which is nice. Type of project, your compliance method. I'm not going to get into one versus the other in this tutorial. Your construction type, for us it's multifamily. Your conditioned floor area. Orientation, if you want to go that route. Sometimes defining the orientation of the building can help you pass if you're in a pinch. I just don't do it. It just adds a lot of complexity to what you already have to calculate. Then you need to select your features based on your job. And then you need to ideally you'd fill out all this information: the address of the job, owner to the agent, designer, contractor. And from there, we get to go put in our information on the envelope. Okay. All right. It doesn't matter what order you do this in, but you just go ahead and start adding. Okay. So I have a floor assembly. It is, for this building, it's an unheated slab on grade. Okay. Take a look at this diagram, specifically the insulation. Up north here, kind of, let's talk Tennessee. I'm on the eastern seaboard here, so you kind of have to make your own judgments, but sort of Tennessee and north for me. To be able to pass without going crazy on your walls, your windows, your roof, you will need foundation insulation. The energy code is pretty clear on this. And these diagrams are super helpful to that end. And what I mean when I say they're pretty clear on, they're very clear that they want that foundation insulation to start at the top of the slab and provide in some way a thermal break, especially at the top, from allowing heat or cold, in our case, to radiate through your foundation wall or through your slab horizontally and then up into your space. The foundation insulation is supposed to be there to break that thermal bridge. It's especially important for the first foot, 6 inches to a foot. That's when your delta T on your ground is the biggest, right? That's why we have frost depth. The deeper you get, the less delta T, the less temperature differential you'll have, the less efficacy you'll get out of your insulation. So for me, I'd say I usually do an R value of 10. That's a 2-inch foam board, and I usually put it down 2 feet. My perimeter, I've done a lot of calculations already. They're very simple. Basically what I do, you can do this in Revit, you can do this in AutoCAD, it does not matter. You need to look at your building, outline the conditioned envelope or the conditioned area. Okay, so because I have unconditioned breezeways, my envelope is broken up into several different quadrants, and my foundation insulation needs to follow that white line all the way around. It needs to be continuous. Again, the thing that I see a lot of folks miss when they do these compliance checks is a lack of understanding what you are calculating. What the software is interested in is the conditioned envelope of your building. No more. It is not interested in the area of your unconditioned porches. It is not interested in the area of your unconditioned breezeways. But what it will be interested in, for example, let's say I had a parking garage underneath my building and that parking garage was unconditioned space. Then I would need to calculate I would need to design for and calculate the area of my floor. Well, instead of doing it as slab on grade, I need to calculate it like it's a regular floor and insulate it. And you saw from the software that those choices are in there. Okay. This, by the way, I pulled this up. This is the software version of it. As you can see, the web-based version is a lot prettier. But we'll go ahead. I digress. My perimeter is 1,700 and we'll call it 5 feet. Make sure you're doing that. That is not an area number. That's just feet, not feet squared. All right. I have a floor. From here, we can add our roof. Now, this is something that I feel like it's been missing or deficient in Reschecks or Comchecks. They don't really consider a 2x4 wood kind of roof. They just offer options. It's my opinion that a steel joist / rafter at 2 feet on center gets you very, very close to a wood. Some people say raised or energy truss. I'm not sure that they define that very well. You can pick either or as far as I'm concerned. I think that when it comes to running the calculations on the software, I've run it both ways and it doesn't seem to make a big difference one way or the other. Okay. Now, I do blown in insulation to a value of R38. I don't have any continuous insulation. And from here, I just need to go get the gross area of the floor, which I believe, let me go double check that real quick. Okay, got it. Got a gross area. Now, again, when you're doing this, bear in mind on the components, you can name it what it is. And for me, it's not a ceiling, it's just my roof. Okay, go ahead and hit apply there. Alright, got the easy bits out of the way. Now we need to go ahead and add our windows, doors, and walls. Let's start with a wall. It's going to be a wood frame, 16 inches on center. Need to go look at my schedule of values. So this, for those of you that haven't seen these kind of calculations before, it's really quite simple. I take the perimeter of my walls and I take the height of the wall and you multiply them together. You add all these up, you get your total area of the wall. People ask me all the time, do I subtract the openings, the doors and the windows from that wall number? The answer is no. They even go so far as to tell you in the software, it'll provide tutorials on that you just put in the value that you get. Don't subtract your openings. The software will subtract your openings for you. So that's 5, 0, 9, I just round up. We'll start off with a cavity, R19, and I'm not going to go with any continuous at this point. Alright, so from here, the nice thing about my building, it's very, very simple. I have one patio door type, I have one double window type, and I have the breezeway apartment entry doors. Which means if I know the number of units, I can very easily add up all the opening areas for those 3 items. All I need to do is put them into the software. We can go ahead and do that now. So we can add a window. So it'll be a parent of wall. It'll be a vinyl frame window. It's a double pane low E window. You can even go so far as to name this what it is in your window schedule. So for me, it's probably going to end up being a window type A. If I change it, I can come back and change this later. My total area for these windows is 3,996. Okay, what do I put for the U factor of a vinyl window? Where do I find this out? These are good questions. Go to a window manufacturer and look it up. That's probably the most accurate way of doing it. The other way to do it is to know kind of what will pass for your building type and and also here's another good one. If you're sort of, let's say that your building needs to pass, say, Energy Star requirements, right? Knowing what those minimum requirements are is a great thing to know right out of the gate. So usually what I put in for a vinyl window, double frame, low E, U factor, very achievable for vinyl windows, like 0.31, 0.32. I know if it's Energy Star, I need to be 0.3. So for now, I know that I don't have any Energy Star values. I'm going to just start out, let's try 0.32. Solar heat gain coefficient, again, look it up. I'm going to say 0.25. Okay. So I can go in here, I can edit this assembly. I can say exterior walls. I can break this down into several different wall types. If it makes it easier on you, you can divide it up. You can have 100 different walls, designate them, you can make a map for it. Again, my building's quite simple, thankfully, so I don't really feel compelled to do that, but if you wanted to, you definitely could. Keeps it a lot cleaner, helps your your drawing reviewer, potentially makes it a lot easier on them to understand what you've done, what you're putting in. Let's do the patio doors. So these will be the entry doors. Gross area for those, 1449 total. Let's put that U factor. This could be like 0.28. I mean, metal doors, solid metal door. It's pretty easy to achieve a very good U factor on those. Let's do another door. These will be the patio doors, will be glazing. Alright, gross area for those triple pane porch doors. 4. Alright, let's give them, this is, now let's try that. Okay. There you go. That's as easy as they can be. Go ahead and save that report. And once it's all in there, you can tell I'm passing by 1.8% above code, which is great. Now, this is the third, sort of the final step that you need to do. When you do these guys, you need to go through your checklist. This is what I was talking about earlier on in the video, where Reschecks don't need direct input from your mechanical and your electrical, but you need to go through here and agree or basically defend why you're not agreeing to a lot of these conditions. Now, the nice thing about this, a lot of these don't really give you the option, right? We have to meet it. We have to meet that requirement. Snow and ice mowing system controls installs. We don't have any snow and ice system controls installed, to my knowledge. So it's just that requirement does not apply. HVAC piping conveying fluids. We don't have any HVAC that's going to use fluid hydrology. It's all pneumatic. It's all air. So that's really not an applicable requirement. Insulation of HVAC piping, again, doesn't really see. Now this one they're leaving a little bit vague because we do insulate ductwork, so I'm going to go ahead and say we'll meet that requirement, and it'll just sort of work itself out. Either they mean the air piping, or they're talking about fluid piping still, and then it won't apply. Hot water pipes are insulated. Yes, we do have water heaters. Yes, you do want to insulate those. Supply ducts and attics are insulated, all right. Yes, we have ducts that are not within the insulated envelope, meaning that our blown-in insulation will be on the underside of our ceiling on the 3rd floor, and the ducts will be potentially sort of above that. So yeah, you want to condition your ducts. That's one of those coordination items you need to let your engineer know. All joints are going, filter boxes are going to be sealed. Sure, it's good to use. Building cavity are not used as ducts or plenums. Yes, everything will be ducted. Duct tightness, yeah, we need to meet that requirement because not all the ducts are within the condition space. Alright, do we want to do a blower door test? Air handler leakage designated by manufacturer at less than or equal to 2% of design airflow. Yes, this is another one. Make sure your mechanical engineer knows that. Programmable thermostats installed. You bet. Heat pump thermostat installed. And heat pumps, yes, we will have heat pumps. Heat pump as opposed to a gas heated furnace where you run your condenser in reverse. Basically, most folks are familiar with having an air conditioning unit where they have a split system. Heat pumps are basically just taking that assembly and running it in reverse. So instead of discharging hot air, instead of cooling a very hot coil outside and then bringing that condensed cooler coil in and then running a fan over that, you're running it in reverse. It's actually pretty cool. A lot of residential houses work that way. If you don't know what a heat pump is, you should definitely look it up. It's pretty easy to Google. Let's see, moving on. Circulating service hot water system is automatic. We do not have a circulating hot water service system. All mechanical ventilation system are not part of tested unless they energy and airflow limits. Yes. We're gonna provide the manuals for the things that we install. Yes. Here's one for electrical. 75% of lamps and permanent fixtures, or 75% of permanent fixtures have high efficiency lamps. Does not apply to low voltage lighting. Sure. Fuel gas systems, pilot light. We don't have gas on this job. Requirement is not applicable. Alright, there we go. We also have to do our envelope checklist. Make sure you do the envelope and the systems checklist. No choice, no choice. Protective covering is installed to protect exposed exterior insulation extends 6 inches below grade. Yeah, so we have foundation insulation that will be exposed in certain locations. We have to protect it. Gotta add that on our drawings. All insulation is level R value, yes. Again, no choice in the matter. Vented attics with air permeable insulation include baffle adjacent to soffit E-vents that extend over the insulation. This is a very important one. You want to have insulation baffles, especially when you do blown-in insulation, to prevent that blown-in insulation from being blown around in the attic and then eventually covering up, say, your soffit vents. Then your attic will no longer vent and the building won't work right. Yes, we're going to do that. No choice. Still no choice in the matter. Agree. Fenestration that is not on site bills listed as does not exceed code limits. Yep. IC rated recessed lighting should be rated. Yes, we do have recessed fixtures. Yes, they need to meet a less than or equal to cubic feet per minute CFM leakage. That's kind of going back to your blower door test. That you need to do that to pass your blower door test. One sort of begets the other. Automatic or gravity dampers on outdoor intakes and exhausts. Yep. Again, no choice in the matter. No choice in the matter. No choice in the matter. That's it. That's really all you need to do for a res check. I want to point out that the Comchecks are very, very, very similar, but they add a little bit more complexity. There's a couple more choices, and we can get into that in a different video. But for now, the last thing you would need to do is print off the report and save it where your job is. Now, normally what we do for these things, we actually put our energy reports on our sheets in our architectural package. And yeah, that's kind of it. Thank you for watching.